Cool. Yeah, so I'm just going to go over some sort of like common JavaScript weirdness, some questions that I get, or some common misunderstandings that I see. Stop and ask questions at any point if you want. If not, we'll crack on. Also, I think all of these apply to TypeScript as well. There might be one bit where the syntax is slightly different, but it should be pretty much transferable. So these are quite basic. We'll just start off with some array logic. So you just got a map. All the map is doing is just going to give replace each item with another one. So I can just quickly do value +1, get my output. And console log the output. Where's my terminal?
There's a problem with your code, Rob.
Yeah, go on.
Yeah, there's no semicolons in it.
Oh, yeah. Thanks, Reese, for useful. Yeah, we are starting quite basic, but I just wanted to show some of the extra things that come through on this. Mainly kind of wanted to talk about reduce, but we'll just start with these. So X each item that comes in, and then we can have the index, and then the actual whole array itself comes through. Same with all the ones in this. Essentially, what that is doing is just taking a function that's going to change every item, and that is going to run multiple times for each item. So we can see here, we get the item through each time, going through once, index, and it passes in the whole array in case you want to do anything with that. Nice and simple. Filter creates a new array. It takes the same lambda definition, so the item, the index, and the whole array. The only difference is that is going to return, expect a Boolean return, and it will filter the list being output. So you can see that as well. 4 runs, and 2 of them made it into the final array. So where things start getting a bit more complicated is reduce, which is slightly different signature. So reduce is generally used to take an array of items and convert them into a single item. So basically reducing it down. So if we do, and this takes what's called the accumulator, which is basically the single item that is passed through each time. Now the flow of this is a little more confusing. So in this case, if we were just looking at totaling up the array itself, what we can do is say, here's the accumulator, and here's each item that's coming through. And what we can do is just return the accumulator plus the item, and then just do that. So you can see that's going through and adding up each item. Just to kind of be clear on the flow for this, because sometimes it gets a little bit confusing. So basically, the accumulator comes in from the second argument here, and that will be the accumulator on the first pass with the first item. Then the return of this is the accumulator on the next item. So if we look at this, we can see we get 0 passed in from here, 0 comes in the first time, then we add X to it, which is going to be 1 in the first case, and then that is the accumulator for the next run. We add 2, that is the accumulator for the next one, 3, and we get the total. The interesting functionality of this is if you don't pass in an initial accumulator, in a simple case like this, when we're not actually going to see a difference in the output. So it's still going to output 10. But what actually happens is the reduce function itself only runs 3 times in this case. So it can be a source of confusion. So if we have a look at that, what actually happens then is the first item in the array is passed in as the accumulator if you don't use an accumulator. So in a case of these numbers, it works just fine because I add the first two items together. But in cases where we're doing more interesting things like mapping arrays into dictionaries and stuff like that, this will cause issues if you don't pass the initial accumulator in. So that's the array stuff. So quickly just touch on truthy, as this is often a source of confusion. So in most languages, or definitely like if we're coming from .NET, an if statement actually requires a Boolean to be inside of it. JavaScript has a lot of logic around actually converting values into Boolean, or what we call true and false, truthy and falsy. So in that case, oops, the concept of yeah. So that, as expected, is going to give us truthy. Now, where JavaScript starts getting slightly more interesting is that pretty much everything is possible to be evaluated to truthy or falsy, and knowing some of the simple ones, it can be quite useful. It can explain code sometimes as well. So I can pass an object in, and that's going to be truthy. Where you generally see this used, which is what I just want to cover mainly, is checking to see if properties are set. So because of this sort of dynamic ability to add properties, sometimes we want to check if they exist or not. So in that case, I'd see something like this. So I'm saying, has that property been set on that object, and basically evaluating truthy or falsy on the value. So if I get rid of that now, that will go into the falsy block. It's always worth checking as well to see what's truthy or falsy if you want to see what happened. There are some very bizarre cases, but I'm not really going to go into the funnier side now. One other note is I get called in sometimes to have a look at stuff, and it's like, oh, some JavaScript code's doing some weird thing. I definitely favor using a REPL. If you get to that point where you're like the code is acting in a really weird way, use a REPL. In .NET, you can use .NET Fiddle. In Node, I think you should just be able to go like that. And that just puts us into a little Node environment where I can just write things like that and then just see what happens very quickly, or just new up a file and write a little script to learn the behavior. It's a lot easier than trying to actually just watch learning. Go and play with it and poke it, see what happens. Cool. So that's truthy and falsy. So now we're just going to have a look at some of the operators. So the operators work a little bit differently, and you can still use them in the same way, but they are probably doing different things under the covers, especially the or and the and operator. So in .NET, we would expect some. So that sort of works as you would expect in .NET or most other languages, that it's saying, oh, that's true. But the OR operator doesn't actually return true or false. It returns one of the sides of the argument. So if we get, and it evaluates not based on whether it's true or false, but whether it's based on, but whether it's truthy or falsy. So if we do that, and we'll just create an empty variable called b. So in this case, b will be falsy, but a will be truthy. So if we have a look at the answer there, what we actually get returned back is the object a itself, rather than true or false. So I think the main reason for this is it gets rid of a couple of operators that languages have had to add. So the two common uses of this are using the or and the and. So in an or, if the left-hand side is true because of shortcutting, I will get the left-hand side. If the right-hand side is, if that's false, then I'll return the right-hand side, whether it's true or false. So that's also worth noting. So if I do, let's C equals 0. So so 0 is falsy, just for clarification. I can see that that is actually going to, it doesn't put back undefined or false, even though both sides are false, it's returning the very right-hand one that is false. So the way shortcutting works is if this is true, return this. Otherwise, just return that. It doesn't matter whether it's true or false. This is the same for the AND operator, except for it's the logic's almost inversed. So if B is false, return B. So in this case, I should get undefined. Whereas if we put A in there, so it's true, I should get C out. I hope that makes sense to everyone. So some of the common cases where we use this is default values. So if I have, let's do a function. So if I have a function that takes a name, because that parameter is optional, what I might just do is say name equals name, or oops, default name. And then we'll just log that out. So if I call that function with no name passed in, what will happen is it'll set name to itself. So if it's true, it'll just keep the same value. If there's no value in it, it will set it to this default name. So that gets default name. But if I then go into the function and pass in I get a restru. So that's just one of the ways that that's used. Then the other one is null propagation. So I think in .NET you have like your question mark dot and your question mark operators. These are all sort of just done with ands and ors normally. So what I'll say is if I've got an object A, and I just want to see if a property exists on A, what I might just do is say if A dot, that's a bad example actually. Yeah, so I want to say const answer equals A dot name, and so A itself might be undefined. So if I were to call that with nothing on it, I should get an error saying that I'm trying to call a property on something that's not defined. So can I read property name if undefined? So the way we would start to handle that is actually if we want to just do a null propagation, let's say A and A dot name. So if A is undefined, answer will be undefined. Otherwise, we'll get A dot name. So I should get undefined through for that. So that's how we do sort of null propagation coalescing. The other thing would be we can use this in combination where we might want to say if it's not set, give it a default value, and then we would just put value on the end like that. And then we see, because that's not their default value, whereas if we create the objects and put name on it, name comes through. Cool. Any questions so far? Okay, we'll keep going then. So I'll just talk about spreading. You might have seen the spread operator, which is just 3 dots littered around. So if sort of common use case for this is I've got an array, 1, 2 in there. Let's have another one with 3, 4. If I wanted to join those two arrays together, if I sort of do A, B like that, if we look down here, what that's actually doing is putting the two arrays inside each other. And you see things like methods to add ranges. One of the simple uses is just use the spread operator for this now. So if I put 3 dots there, 3 dots there, what that's actually going to do is take each item from the array and put it into the new array. So see there, we get the two arrays merged as we expect. So interestingly, this can also be used on objects as well. So one way, if we wanted to create a new object from that, originally what we would have had to do sort of to merge those together is either do something looping through the keys on the object or manually update something. So we just say name equals a.name and prop is b.prop. Obviously, if we keep adding more properties to these, or we want a generic method that operates across different object types, this is going to become a problem. But that should give us the output we're looking for. So that's joining them together into the same object. This will sort of start having problems. So if I start going like that, we're not going to add that on. So we just use object spreading now. So we can just say .a, .b. And that is going to put all of the properties of both of those objects onto the final one. Like that. And then if we add more, they'll keep going through. This can also be used for default values as well. If I potentially have an object and if they don't pass certain values, so I can default them just using the order. So let's say I have a property called over, and my default value, so this is going to be the default property. If I do that now, we will see I get over is default, but if the second one that goes in will overwrite that. So it can be a useful little mechanic for creating default values for objects. Right. So this stuff also interestingly works on parameters. I'll just create a quick function there, and we'll just lock that on. So we can call that with 1, 2, 3. So what I can do there now is just do something like ... params. Put params in there. And then the console log is going to give us an array. So it's a quick way to get an array of the parameters passed in, so allowing you to have methods that can take multiple amounts of parameters. With spread as well, you can also do sort of rest. So I can say, here's the first, and here's the rest of the parameters. So you see it just takes the first one, then gives you an array of the rest. You can also do this when you're spreading into arrays as well. So if I was, like before, if I was doing sort of, I can just say, or can you? No, you can't. I'm losing the plot. Okay. Oh. So just going to have a quick look at deconstruction now as well. So deconstruction is just like syntactic sugar, really, just to make variable naming a bit easier. So if I've got a function like this, in fact, we'll start with a non-function example. So can't say. So I've got an object, it's got a name property on it. If I want to just treat that as name, what I can do is deconstruct the object. In order to do that is I basically write it out like this. So, and then I should be able to do name. So I can just use the name property now as a name variable. So that reads out there the name value. So where this starts becoming useful is in functions. So I'm going to pass, if I was passing this to func, within func I have my object coming in, and to access that I start saying object.name. So that's like an now, but what I can do is just deconstruct inline in the parameter list. So a lot of the time if I'm operating on one object, actually I'm just using that for everything. So if I just split it out, it also makes the method a little clearer in like type of scenarios where it says like, this is what this method cares about. It only cares about these properties rather than not being able to see what it's using on the object easily. So I can just do that. So there are a few extra things you can do with that as well, where the syntax gets a little bit more complicated. I don't really see them used that often, so maybe it's an advisory against using them. So one is you can rename in there. So if I wanted to say, actually, I want to call name username, do that. So that works. Don't generally see it used that often. And even less is sub-properties. So I can do is say property is actually, I just want to test off property like that. Should get, so I get the value of that right out there. Interestingly, if you are doing this, you can also get prop the object out as well. So you can sort of reuse variables twice. Again, don't really see it used. Also, you can deconstruct arrays. So we might have name, I don't know, value. It's similar syntax. I would just say, but rather being based on a key value pair, this is then going to work based off the index, so the order in the array. So see them coming through. You can also do this in your functions as well. So you can just say, okay, I want name, value, and then you can also have sort of multiple parameters as well if you want. Cool. So that's deconstruction. So I'm going to briefly touch on some of the async patterns. I imagine for some people this will just be like, oh, that's easy, and other people will probably just not have looked into them that much at all in the struggle. So if anyone wants me to do like a more in-depth talk on that later, just let me know. So for this, let's just do a HTTP request. I'm just going to create a function to do a sort of fake HTTP request, and that's going to take the URL, and then we'll just use a timeout to sort of act as if it's going and doing something. So let's just run that and see what we're getting. Cool. So what we're seeing is this goes in there and calls that, and then there's a short time, and then this gets done. So just to be clear, let's just put an end of file in here. So if we look at the order now, you'll get calling that, then the end of the file down here, and then the timeout. So often what we want to do with these patterns is say after this is done, do something else. The basic one in Node is callbacks, which you do see across some JavaScript. So the function itself will just take a callback to say do this after. And then in here, this is just going to say callback with a response. Just to quickly dig into that. So the flow of this is come in here, execute this, then go in here, get the calling URL. The end of the file then, so the thread finishes and goes down here. Then after the timeout is complete, we get request done. We call back, then that comes in here and executes this function, and we get after. And the response passed out. So that's just sort of showing how the asynchronous side of requests. So the next common pattern is to use promises, which just basically change the syntax around this to avoid some things where the syntax starts looking really horrible. So in that case, if I want to create a promise, I can say return new promise. And the promise just takes a function that will execute the moment the promise is created, and it just has this resolve and reject. And resolve is just essentially the same as your callback. When you hit resolve, that is going to complete the promise. It's very similar to sort of tasks in .NET. So if we just move this into here, and then the syntax essentially for promises is just to say dot then, and then that'll get that through. Clear that up a bit. We should, if I've done it right, get the same order. Oh, no, that. Oops, that needs to be resolved. Cool, so we see the same thing. When we trigger this promise, that is then doing the creation, return the promise out. The promise then does nothing, so we hit the end of the file. That timeout then finishes, we get request done, we call resolve, and then we go into this then block. The main reasons around this being a more powerful syntax is if this returns another promise, it bubbles out. But generally now, I'd say most people just go off and use async await because the code looks a bit more synchronous. In most cases, probably a lot easier to understand. So it's just a quick sort of gotcha with async await. You can't do async await in Node, definitely at the file level. It has to be within an async function. So if I just create that, so I just call it an async function. And then if I wanted to execute that at the top level, I just have to execute it like a promise. So that's just going to execute into here, and then I should be essentially able to rewrite this. So async await under the covers still uses promises if you're actually defining a task that can take some time. It's just when you're calling them, the syntax is sort of different. So in here, what I would say is const res equals await HTTP request. And then I can just do console.log after is res. Now these two things should be equivalent. The only sort of difference is the syntax and how you're executing it. Generally, I'd say most people end up preferring this because it just looks like more synchronous code. but it is a little bit of a gotcha for new people coming on because they're not really understanding what is happening when you're using this await word. And you see people getting confused on the order that things are coming back in. So it's definitely worth spending some time with to understand what's going on. Just run that and go through it. So see again, come in here, we're executing this function. That is then going to do the request. So say we're calling, we then hit the end of the file because that just returns a promise and then nothing happens because this is awaiting the response. So that code just essentially stops at that point. And then when the timeout triggers, we get request done. That hits resolve, which is then going to say this await is finished. So it's going to put that value in there. Then we get after and the value, and then we get the async complete. That's cool. Yeah, like I say, if anyone wants a bit more in depth on sort of like, I guess, async in general across languages, I'm looking at sort of testers juniors, like I'd be happy to put together a talk on that as well. Aside from that, any questions?
Do you want to go over the, with the operators, I think one of the big advantages there that you didn't mention was the immutability of it. I don't know if you wanted to talk about that or if you kind of skipped over it.
Go on, explain, tell me what you want me to write out. I'm not following.
Just how, like, when you use like the map, it's all immutable. It returns a brand new array. And
oh, okay. So with the array stuff, yeah, that's a really good point. Go back in time. Yeah, so an important part of map and filter is that they return a new array. They do not alter the existing array, which is really good for sort of not messing up state. Happy?
I'm never happy, Robert.
Yeah. Anyone else got any other questions? I guess also with async stuff is like you're then getting into potentially like RxJS and stuff like that, which is another sort of interesting paradigm, which I think there's talks on the YouTube, isn't it? If not, we'll make something we want to.
I'd love to go more async stuff at some point.
Yeah, I'll sort of sound people out and maybe do a quick talk on it, or maybe a bit more of an in-depth talk. Cool. Any more questions? Anyone want to kill the recording then?